Okay, so today we're going to take a look at a thing called the sine law, also known as the sine sausage. You'll see why we usually call this the sine sausage. And the reason why is when we usually do a regular class, I'm doing this just before lunch, right? Now, so here's what we need to recognize. We need to recognize that in any triangle has a sine sausage. That means we have a matching angle with its side. So, for example, here is one sine sausage. Okay? So if you look, for angle A, we have side A on the opposite side. For angle C, we have side C on the opposite side. And for angle B, we have side B on the opposite side. Okay? Now, the reason why I call these a sine sausage is because we actually match the side and the angle with the other side and its angle. And, wait for it, angle C and C. And all of those look like sausages, don't they? So it's kind of like when you're looking at a triangle that might have sine law, you have the numbers for the angle and its matching side. That is what we know is a sine law type problem. So here are the possibilities for sides of the sine law. So what that means, for every triangle, we have its side over the sine of the angle. So in this case, we have side A over sine A equals sine B over side B, which is side C over side C. So all of those fractions are equal to each other. Now, that's if we're looking to find the side of a triangle based on the sine sausage or sine law. Now, if we're trying to find an angle, we start with the sine of the angle on the top of the fraction. So we have sine A over A equals sine B over B equals sine C over C. So now, when we're doing any of these problems, we have to determine which one we're going to use. We're either trying to find the side of a triangle or we're trying to find the angle of a triangle. So therefore, you have this one for our sides and this one for our angles. And the best part about it is once you've decided what you're going to do, we could use any two of these. So maybe I could use sine A over A equals sine B over B, right? Or I could use sine B over B equals sine C over C. Or I could, if I was looking for sides, I might have sine A over A equals sine C is equals to C over sine C. We use any two of those fractions. And the key is to find a number and an angle that have all the numbers in it. And that allows us to go and bring all this stuff together. You'll see as we do some practice. So just quickly pause the video and then we'll move on. Copy this and then we'll move on to the first example. All right, for the first example, we have find the measure of a side and here is what we're talking about. So imagine we have this first example. You have a triangle ABC with angle 50 for B, angle 70 for C, and 25, and side B is 25 centimeters. You know this is a sine sausage question because of the fact that we have side B and angle B as numbers in the problem. And because of that, that means if we know one angle or a side of the other thing, then we can kind of bring it together. So let's take a look at the picture that you would see. So suppose I have this triangle ABC, right? Let's take a look at what we have. We have angle B is 50. So I'm just going to put that in here. Angle C is 70. And side B is 25. So side B is directly across from B. So this is 25 centimeters. So basically what we could do is we could match our sine sausages. So in this case, we have 50 and 25 as one sine sausage. And then what we're looking for is little c, which ends up being on this side of our triangle, which means we have angle C and side C matching. So now, here's the best part. We set up the stuff that we're missing on the left side. So remember, we are using sine sausage with a side. So we're going to use this equation that we have right here. We have side over the sine of the angle equals side over the side of the angle, and we're only using two of these. So let's do that right now. So if we're looking at our problem, we're literally going to have this. Remember, what we're looking for is on the left side. So you're going to get sine, so C over sine C equals B over sine B. And you know you got it right if you know that the right side has all numbers on it, okay? And there's only one missing thing on the left side. So let's go and test it by filling out what we know. So you've got C over sine of 70 is equal to, well, 25 over sine of 50. Now, here's how you solve it. So we go and calculate the sine of 70, all right, and we replace it. So we have C over 0.939 is equal to, well, 25 over, well, sine of 50 is 0.766. So now we can take a look at this, and isn't that just cross product now? So we're just going to cross product these things. So we're going to get the following. 0.766C is equal to 25 times 0.939. So in order to save some time, what I like to do is I like to get rid of the C on the left side. So I'm going to divide both sides by 0.766. And you'll notice that I didn't just calculate right away. So that means C in its final form, like Vegeta, is going to be 25 times 0.939. And then we're dividing that by 0.766. So now that I have that, all we have to do is we have to calculate C by just doing this calculation. So remember, we're going to do the top first. We're going to go 25 times 0.939, and then we're going to divide by 0.766. Try that out on your calculator, and you should get about 30.7 centimeters. Now, let's go and look at the title of this problem. It says, find A when you're given the measure of a side, right? So when we're looking for the measure of the side, you're actually given two angles. So that's A and S, but because you know the one angle that's missing, so if I asked you how to find, so let's say I asked you to find some other stuff, right? So imagine I wanted to find angle A. All we're going to do is just go angle A is equal to 180 minus 70 minus 50. And that gives us angle A is equal to 60 degrees. And I could use that and punch it into my equation. And then I could go and find, if I have angle A, then I could find angle B, side A with the angle 60, right? But we'll always have to use our first ratio, of 50 over 25 and 50 for our sine sausage, right? Okay, so now let's move on to example 2. Okay, here we go. So this problem is asking us to find the measure of an angle when you're given this, and that only happens when you're given the following. You're given an angle, a side, and a side. Okay? So let's go and take a look at this triangle XYZ with side X equals 10 and side Y equals 4, with angle X being 80 degrees. So let's just quickly draw that. So now you've got your triangle, and then you're going to label all the corners. So I'm going to call this X, Y, and Z. And you'll notice how I draw those really big. And then I have their missing sides. So for side X, if this is X, then its opposite side, little x, is 10. So we're going to write 10 meters here. Okay. All right. Now for Y, here is Y. So its missing angle is this side here. So it's opposite to here. So there's where we are. So we're going to write, for that, we're going to write 4 meters. Okay. And for angle X, so for angle X, we have 80. So we'll just put that in. So 80 degrees. So we have 80 degrees here. So remember, when we had our equations, we always start with, if we're looking for angles, we're using this one. Sine of the angle over the side equals sine of the something over the something. Now, let's go back to our problem. All right, so for example 2, what are we looking for? In this case, we're looking for angle Y. So we need to have sine of Y on the top. Sine of big Y over little y is equal to, well, let's see what our sausages are. So here's what we're going to do. We're going to go and select it. So X and X is one sausage, and the other sausage that includes Y is this one. So we have sine Y over Y equals sine of X over X. So now let's substitute directly in. So sine of Y, we substitute in, we don't know what it is, so we get this. So you get sine of Y over 4 equals sine of 80 degrees over 10. Now, in order to cut down on the amount of work that we're going to do for these ones, what we're going to do is we're literally going to just, if I have this on the bottom, we're going to do kind of like a cross product, but we're going to cut down on the work. So if I have sine of Y over Y, so the key idea would be just take the 4 that's on the bottom and just move it over to the right side. Okay, so now that you've got that, you've got sine of Y is equal to 4 times sine of 80 divided by 10. Now, so that means once I calculate this thing over here, we're going to have a decimal. So we're going to go 4 times sine of 80 divided by 10. Just use your calculator and punch it in. So you get 0.3939 is sine of Y. So now, in order to figure out what Y is, we're going to have to write Y is equal to, angle Y is now equal to sine inverse of 0.3939, and you end up with Y, angle Y is equal to about 23.2 degrees. All right. Now, most times I ask for the whole number. Sometimes you can just leave it to the decimal and I'll give you the full marks. Okay. Now pause the video if you have to. Review this and watch it again. Let's move on to the next question. So these two ships are located about 15 miles apart. So if I'm looking at this first bit here, it tells us that the two ships are 15 miles apart. So what we can do is we can immediately write 15 mile between the two. Okay. Now, the second part of this problem, this nautical ship problem, is, well, the angle to the entrance of the port. So this is the port here, right? For alpha, beta's angle to the entrance of the port is 45 with respect to beta. Okay, so here is beta, here is C. So that means the angle between them is 45 degrees. All right, so beta's angle with respect to the port and alpha is 45 degrees. So basically, the angle between here and here is 45 degrees. So now, and then alpha's angle to the entrance of the port is 55 with respect to beta. So that means here's beta, here's its entrance port, and then we put 55 degrees for this angle. So now the key idea is we need to identify what the sine sausages are. So in this case, we have a sine sausage that happens between here and here, right? But here's the best part. We have two angles, 55 and 45, right? Which means that the missing angle for C is 80 degrees because we take 180 minus those two other angles to get 80 degrees. So now we need to find which ship is closer. So we're either looking for this or we're looking for this. Okay. So for side B here, I'll call it little b, we're going to do the following. Now, since we're looking for sides, we have to do B over sine B. Okay. And since we're looking for B, that's going to be on the left side of our equation. And then we're going to use the sine sausage that we have for 15 and 80. So we're going to have sine B is sine C is C over sine C. So let's substitute directly in. So we've got 15 over sine of 80 is equal to B over sine of 45. So remember, when we solve for these ones, we can basically make our life easy by just taking whatever's on the bottom and moving it to the top of the other equation. So we end up with B is equal to 15 sine 45 divided by sine of 80. So that means B is going to be approximately 10.8 miles. So we'll just write 10.8 on our thing. All right, so now that we have our 10.8 miles calculated, we still have to find out what this side is, okay? In order to find that side, what we're going to do is we're going to match it with this angle, and we're going to call this side A. So let's do our calculations for side A. Now, we have A over sine of A is equal to, well, we'll use our original sine sausage, which is the 15 and the 80. So we have C over sine of C. And then C over sine C is just 15 over sine of 80. And A over sine of 55. So now let's go and do the math that we did before, where we just changed the sine of 80 into a decimal and the sine of 55 into a decimal. So now you're going to get A over 0.819 is equal to 15 over 0.9848, 9848. And here we go. So now, in order to get rid of this number that's on the bottom, we're going to take it and we're going to plop it onto the top of the fraction, because it's division on the left side becomes multiplication on the top on the right side. So now we end up with, well, A is equal to 15 times 0.819 divided by 0.9848. And you end up with A is equal to, well, about 12.5 miles. So the distance is 12.5 miles. This, if you do nothing on your tests for me, make sure that you basically at least write out the triangle calculations on your sheet, so we know what we're looking for. So the very last thing that it asks you for, it wants to know which ship is closer, right? So the closer ship is this one, which is alpha. So let's write that out. The closer ship, the closer one is alpha. And it is 10.8 miles from port. So that's it. That's how we do this. So just as a quick reminder, go back to the beginning and go over your concept for sine sausage. So if you don't, this is it. So for our sides, for the sine sausage, we have A over sine of A equals B over sine of B equals C over sine of C. Or we're going to have, if we're looking for angles, we want to have sine on the top. So we have sine of A over little a is equal to sine of B over little b equals sine of big C over little c, where C's are angles and big B's and C's and A's are all angles, and little a's and little b's and little c's are sides. So your homework are these questions that I have posted here. Okay? All right. Good luck.